mixing or transport is called shear flow dispersion. This occurs because of it is a diffusion type transport process. It occurs due to non-uniform velocity distribution. It can be explained over here. Let us assume we have a channel and we have a uniform distribution of the velocity in all along the channel cross section. We are seeing the plan view, I think, over here. We have a uniform velocity distribution. Whatever is the velocity in the middle of the channel, same is the velocity at the bank of the channel, same is the velocity at the bed of the channel. So there will be diffusion occurring along the length of the channel, but with respect to the boundaries of the channel, there will be no difference. There will be a uniform concentration at time t1 at some place downstream, at another time t2, another uniform concentration will be there. If we see these variation of the concentration, we can get a good normal distribution curves over here. But actually, the channel don't have such kind of uniform velocities over there. We know that in an open channel or in pipes, velocity vary as we move from the boundary towards the center of the channel or the pipe. So velocities near the bed, velocity near the bank is very small, and velocity at the center of the channel is quite high. Or as we go from the bed to the top surface, velocity increases. So velocity distribution is not uniform, rather it takes a shape as shown over here. Non-uniform velocity distribution is shown over here. So when velocity is different, so the concentration is also not same close to the bed and close to the banks and at the center. So there is a non-uniform concentration distribution. This non-uniform concentration distribution results into another concentration gradient. So that also help in diffusion of the particles or the constituent. So this non-uniform velocity causes non-uniform concentration from the bed to the center of the channel, and that non-uniform concentration gives rise to another kind of gradient, concentration gradient, and then that also causes the diffusivity or mixing of the salts or constituent. And this kind of diffusion is called as shear flow dispersion. Over here they are showing you a non-uniform velocity distribution. This will cause non-uniform concentration of the constituent, and that will result in another kind of diffusivity known as shear flow dispersion. All of this is explained over here, what I have told you. When velocity is uniform, so read it over here. So it occurs when velocity is non-uniform, an additional longitudinal mixing, it occurs. That is called as shear flow dispersion. And why do it occur? It occurs because the differential advection and consequent retardation of the tracer near stream boundaries. बाउंड्री के करीब चूंकि वेलोसिटी रिटार्ड हो रही होती है या कम हो रही होती है, तो कंसंट्रेशन भी वहां पे कम होती है. तो सेंटर और बाउंड्री के दरमियान में देयर इज अ कंसंट्रेशन ग्रेडियंट, डेल्टा सी और डेल्टा एक्स वहां पे पैदा हो जाएगा. So that causes an additional diffusivity. Close to the point of injection, 3D or 2D analysis should be carried out because of this shear flow dispersion. And far away from the injection place, we can carry out only 1D diffusivity. But it has been seen that this longitudinal diffusivity, which is because of this shear flow dispersion, that should be taken as the coefficient of diffusivity. So flux should be calculated in 1D using the longitudinal diffusivity coefficient, which is 100 to 1000 times greater than the turbulent diffusivity. This shear flow diffusivity in longitudinal direction is 100 to 1000 times greater than the turbulent diffusivity, and this diffusivity is different in x direction, in y and z direction. So that's the reason that if we are analyzing a near flow, near field analysis, then we should go to 2D, 3D analysis. If we are analyzing at the far field analysis we are doing, then only the longitudinal dispersion diffusivity we can take. and we can calculate the flux. So we have seen three kind of diffusivity. One, molecular, very small, chemists are interested in it. One, turbulent diffusivity, that is of interest for the river flows, but that is overcome by another kind of diffusivity. We call it shear flow dispersion or shear flow diffusivity, that is contributing much towards the dispersion of the constituent. The term dispersion is commonly used to refer to the diffusive type of the mixing, but in surface water studies, it should be reserved for shear flow dispersion. So this formula, fixed formula, is used for diffusivity flux, and EL should be used for that.